Welcome all. Matrix, you have to write matrix matrix. Whatever vector you have, that you have already. See, this is a vector. Or if you don't want, you can take it. You write here. D is the vector. So we have already a vector. That vector is here. They are the same thing. So either you start within the matrix or you make a vector, you name it D matrix D. Only I will write D. It says what you can write here. Okay. Suppose I will run these two. See what happens. So 17, 61, 15, 12, 11, 99. So if you write matrix D, you are getting this. But you only print D. What you will get? See, print D means you get in row. When you write matrix D, then you are getting this way. So if you write number of rows n row 2, so if I print I here, see I got here. So with two rows I need to manage the vector. In the vector initially I had 6 elements, and now you have to divide the 6 elements in 2 rows and 3 columns. Number of columns you don't need to write, because row multiplied by column will give you the total number of elements. We have another matrix J. It's not a different one, it's the same type. Okay, we got another vector. Now we'll see whether we can add two matrices or not. Sorry, this is another matrix. I is a matrix, J is a matrix. I plus J will find, and we'll try to find I multiplied by J, and we'll see what we are getting actually. Whatever we want, we will get that or not. Minus, if you write, you will get minus for sure. Now if you add element by element, it will add. If you multiply element by element, it will multiply. But we don't want that. We want a matrix multiplication. This is not matrix multiplication. This is element by element multiplication. If you want, you can multiply 15 with 26, you will get 165. Here we have I, here we have J. If we multiply 11 with 15, you will get 165. I multiplied by J. But we want matrix multiplication. So element by element multiplication is not matrix multiplication. If you want matrix multiplication, then for that you have to write percentage star percentage. This is matrix multiplication. If you don't write percent here and percent here, this will be element by element multiplication. Now again in the matrix, in L we have taken 1 to 15 and number of rows 3, then number of columns will be 5. So all the elements from 1 to 15 you will see here in L. And if you see K here, randomly we have elements, number of rows written. By row is equal to true. By row is equal to true when you write. What is the meaning of that? Suppose I will not write that one. I will write only print this. Initially we started with only number of rows. Now we'll print this one and we'll write it KK. So let's print KK. Number of rows 2. Okay, so 2 rows 3 columns. You see 2 rows 3 columns. But how the elements are taken? Like first 12, then in the column 6, see the output.
Yes, sir.
Then 5 comes, then 32 comes. So by default it will fill the first column, then it will go to the second column, then it will go to the third column. But if you write by row is equal to true, if you add that one and you run, see 12, 6, 5, that means by row true means T you have to write. See here syntax.
Yes, sir. I wrote 2.
Yeah, by row true means By row it will fill elements.
Okay, okay. Okay, sir.
Yeah. If you don't write anything, it will take default by column.
Okay, okay.
So that's why if you want your elements to fill by row, you have to write by row is equal to true. Now number of row, then by row. These are the two things in addition to the vector you need within the matrix. Now let's go to the next matrix. Here also number of rows 3, but instead of
I
writing elements like this, we have written 1 to 15. See, by rows it took, and in 2 rows, 3 rows, everything completed.
yes. Yes, sir.
That's why we have written by row true.
I wrote.
Now we have to decide, can you multiply these two matrices, this matrix and this matrix. Remember, when you apply matrix multiplication, this you multiply with this column, right?
Yes, sir.
So first row with first column,
Okay.
then first row second column,
Column.
first row third column, first row fourth column, first row fifth column.
Yes, sir.
That will be our first row of the matrix multiplication. When I say first row first column, it's actually 12 multiplied by 1 plus 6 multiplied by 6 plus 5 multiplied by 11. So you will get 1 plus, I am saying you will get one element that will be the first row first column element of the multiplied matrix. So you have to multiply the first row first column. When I say first row first column, it's actually just a minute, where it is. This window, it went there. Okay. Now when I say first row first column, that means it's 12 multiplied by 6.
One.
It's 12 multiplied by 6. 12 multiplied by 1
One.
plus 6 multiplied by 6 plus,
Not.
so you get one element. That element will be here, 103. Then you have to complete the row, then only you can go to second row. First row you have to complete. So when you multiply this by this, you got actually this multiplied by this, you got first element. Then this multiplied by this, you will get second element of the first row. This multiplied by this, you will get the third element of the first row. This multiplied by this, you will get fifth element of first row. So if this is one element, you will have another element, you will have another element, next you will have another element, 3, 4, then the last one you have to find. Last one will be 12 multiplied by 5, 60, 6 multiplied by 10, 60, 120, 5 multiplied by 15, 75, 120, 75, 195. So this is my first row. Then second row first column, second row second column, second row third column, second row fourth column, second row fifth column. If you do this way, you will get second row. That's all. So we'll have only 2 rows. We'll have only 2 rows. That's all. The problem is, if you have two elements here but 3 here, you can multiply. Suppose you have only 2 columns here, you can't multiply. Matrix multiplication here will not exist, because You have to check only this one. You don't need to remember anything. When you multiply this one with this one, that's fine. When you multiply this one with this one, that's fine. There is nothing here. That's the problem. So the number of columns here must match with the number of rows here.
Okay.
The number of columns in the first matrix 3. Now here 2, that is the problem. The number of columns in the first matrix must be equal to the number of rows in the second matrix. Then matrix multiplication will work. Now if you come here, you can check that. We'll see whether it will work or not. I must have taken properly. Yeah, it worked. That means if you check here, how many columns we have in L? We are doing K then L, okay? So number of columns in K, number of rows in L, they must match, okay? That way you can check. Now suppose T of K you write, okay? K is a matrix. Here this is the first one, not the multiplied one. See, we have not given name for this one, okay? If you give a name here, with that name you can print. Suppose P I will write this way, then you can, if you print P, you will get the multiplication in P. That is saved. It's not saved now. Anyway. Now T of K means transpose. That is also required.
Transpose.
Yeah,
Okay.
transpose. Means rows will be columns, columns will be row that way.
Yes, sir.
Dimension, you know, row multiplied by column, dimension. So that is DIM you have to write. Okay. So if you run this, see, class means it's a matrix array. That way you will get. Okay. Dimension 2 cross 3. That way you will get. Then attributes. If you write attributes K, you will get this way. DIM and 2 cross 3. That's all. I mean, nothing more you will get. That's not an important one attribute. Now, suppose you want to name the row names and column names, okay? So here K I will write, and I will write column names, COL names, okay? If you do that, then what will happen? Column names K, call names, COL names, okay? You give and then print. See now. Yeah, because this is not proper. How many columns are there in K? We have 3 rows, more columns, right? How many columns are here? In K, we have number of rows 2. 1, 2, 3, 4, 5, 6. 2 rows, 3 columns. We have 3 columns. So 2 rows, right? So here this one will change, okay? Here call names you do. So call names you do. This one row names. So first we'll do row names, then we'll check K once again. See now AB, right? Row names. You have given names to row, that's all.
Yes, sir.
Now if you want to give names to columns, then you write this and run once again. Now we have row name and column name. Acha. Now there is another way you can make a matrix. The other way is, this is one vector, this is one vector. You can write C bind. Okay, C bind is one syntax R programming syntax. So it will bind these two.
Okay.
How it will bind? C bind, not R bind. Okay. So C bind means how you get 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. C means C here stands for column bind. Okay. Like you make this as first column, make this as second column. If you write the same one as R bind, it will bind in rows. See 1, 2, 3, 4, 5, 6. T of 2. How you know T of 2? 13, right? What is T here? First of all, when you find T of 2, you need to decide what is T, right? So T is a vector here. C is it's a vector. So second element, second room value you want, that gives you 13. You run it and check whether you get two elements or not. 10, 24. So not only the first one, you got the third one as well. 10, 24. So if you want to print two elements from the vector, not one element, you have to write corresponding rooms and you have to enclose and you have to write C. You have to make like a vector.
Okay.
Yeah. Or maybe if you write this way, all you get. That's the problem. I mean, this will not be skipped 13. If you write 1 is to 3, then you will get all elements 10, 13, 24. Okay. Now matrix 1 to 9, this we know already. No repetition. Now arrays, multi-dimensional vector. When you talk about array here, 1 to 30, okay, dimension 2, 3, 5. That means this is many matrices you get here. Okay. 2, 3, 2 cross 3. How? What is that? 6.
Six.
So 6 element, 5 matrices you will get. That is array.
Okay.
So many matrices you get. So 30 elements when you are keeping, you have to make it sure that this multiplication will be 30. The 30 elements you want to keep in 5 2 cross 3 matrices. That is the array. Okay.
Okay.
If you see 5 matrices actually. Which is the first one? This is the first one. 1, 2, 3, 4, 5, 6. By default, it's taking in columns 7, 8, 9, 10, 11, 12. So if you get many matrices, if you want to keep all the elements in many matrices, suppose you have 5 crore rupees. You want to purchase 5 houses with 4 rooms, right? Instead of purchasing a one house, 5 crore house, you want to purchase 5 houses. In each house there are 5 rooms or 4 rooms. That way. We want to fill all the elements in many matrices of 2 cross 3. That's the array here. Array means, okay. Now if you see class here, it says only array. Single matrix is also an array, right? You write class of K, you will be able to know. Matrix array. So suppose I will write it 6 cross 5 and 1. Then let me run this. Only one, right? See, first one it says, okay.
Only one.
Only one you got, 30 elements are here. Now you check what it says. Now if you check here, only array, right? This is a matrix, but it's not saying matrix array. It says only array, because although it's single matrix, we have used this array. That means it takes as an array.